Section 13.8, extrema of functions of two variables. Let z be a function of x, y. To find the extrema d, we're going to use this rule. The second derivative of f with respect to the x, the second derivative of f with respect to the y, and fxy squared. If d is equal to 0, it's indeterminate. If d is greater than 0, now we have two options. We're going to depend about the second derivative of x with respect to the x. If it's less than 0, is going to be maximum. If it's greater than 0, is going to be minimum. If d is less than 0, is going to be a saddle point. Let's start with the first example. On this section, we need to find the extrema point, if it's maximum or minimum. So the first thing we're going to do is find the first derivative of x. We need to find the critical point. That means g of x equals 0 and g of y equals 0, because we need to find the critical points. So g of x is going to be 2x minus 5 to the power 1 plus 0. And this one is going to be 2x minus 10 equal 2x minus 10 equals 0. Because g of x is 0, that means 2x or x equals 10 over 2 is going to be 5. Now, g of y is going to be equal, with respect to the y, is going to be, this one is 0, so it's going to be 2y minus 1. And then it's going to be 2y minus 2 equals 0. And that means y is going to be equal 1. So now I have x and y. These are the critical point numbers. And then next step, we're going to find the second derivative test. So g sub x is going to be, this is g of x. G sub x is going to be only equal 2, because this is 1 and this is 0. So it's going to be 2. Or if you want to check that, we can find the derivative for this one, which is going to be 2. G sub y is going to be, so here is the g of y, check the derivative of g of y, it's going to be also 2. G of x, we're going to take the derivative with respect to the y. So here is g of x, take the derivative with respect to the y, is going to be 0. So this is the second derivative test. Now, our d is going to be g sub x times g sub y minus g sub xy squared, which is equal 2 times 2 minus 0 squared. And this one equal 4, which is greater than 0. Then, greater than 0, g sub x equal 2, also greater than 0. So d greater than 0, this one greater than 0. So the point xyz is going to be a minimum, extreme minimum. So that means it's going to be minimum. Let's find the point. I have x and y. We're going to plug in x and y here to find the z. So z is going to be equal g of x is 5 and y is 1, which is equal 5 minus 5 squared plus 1 minus 1 squared. And this one, 5 minus 5 is going to be 0 squared plus 0 squared and equals 0. That means z equals 0. So the point is going to be x is 5, y is 1, and z is 0 is extrema minimum. That's it for this example. Let's check. Here we go, we got it right. And because we got extrema minimum, so you're gonna put here on the maximum does not exist. Let's go to the next example. Example 2, f to the xy equals square root of x squared plus y squared plus 49. Before I start with this one, I'm gonna find the critical point with x, y, z. So the first thing what I'm going to do here now, I'm gonna, because this is radical, so I'm gonna say this one is going to be x squared plus y squared plus 49 to the power half. Now let's find f sub x, which is going to be half the function plus y squared plus 49 to the negative half times the derivative of everything inside, which is 2x. Cancel the 2 with the 2. So it's going to be everything here, x over the square root of x squared plus y squared plus 49. Now, alpha for the x equals 0. To find the extrema, that means x over square root of x squared plus y squared plus 49 is going to be equal 0. In this case, we're going to get x equal 0. Then we're going to do the same thing for the y. So f sub y is going to be, we're going to find the derivative with respect to the y, is going to be half x squared plus y squared plus 49 to the negative half times 2y. The derivative of f with respect to the y. This is 0, this is 0. Cancel the 2 with the 2. So the result is going to be equal y over the square root of x squared plus y squared plus 49. Now, f sub y equals 0. In this case, y over the square root of x squared plus y squared plus 49 equals 0. That means we're going to get y equals 0. Now I'm going to find the z. So I'm going to get the critical point. Then I'm going to test this critical point is going to be extrema maximum or minimum. Now I'm going to plug in x and y here to find the z. So z is going to be here or here, the same thing. 0 squared plus 0 squared plus 49 to the half. That means it's equal 49 to the power half, which is the square root of 49 equals 7. That means our critical point is 0, 0, and 7. This is our critical point. Now we're going to test this critical point is extrema maximum or minimum. We're going to go ahead and work on the second derivative. Now f, here is our f sub x. We can write down this function as, because I need to find the second derivative. So I'm going to say this is x squared plus y squared plus 49 to the power half, negative half. I'm going to work on this side. So it's going to be the product of two functions. The first one times the second one times the first one to find like a chain rule. Then the same thing here. When we need to find the second derivative with respect to the y, I'm going to say this is y and x squared plus y squared plus 49 to the negative half. So I'm going to use these two functions when I need to find the second derivative. Now, f sub x, the second derivative with respect to the x, that's mean this one. So it's going to be x times the derivative for the first one. Here is x times the derivative for the first one, which is going to be with negative half, so it's going to be negative half x squared plus y squared plus 49 to the power negative half minus 1, negative 3 over 2, times the derivative of inside, which is 2x, plus the second one times the derivative for the first one. So here's the second one, which is x squared plus y squared. We don't have to put a bracket. Plus 49 to the negative half times the derivative for the first one is 1. Let's keep going. So now you're gonna simplify because this 2 goes with this one. We're gonna multiply x times negative x times x is going to be negative x squared. So here is going to be negative x squared and x squared plus y squared plus 49 negative 3 over 2 plus, I'm just simplifying, this one is going to be x squared plus y squared plus 49 to the negative half, because this is 1. Now I'm going to take as a common, which is negative 3 over 2 between these two. So x squared plus y squared plus 49 as negative 3 over 2. The left is going to be negative x squared from this side, and from the other side, negative 3 over 2 times negative half is going. You're going to add it. It's going to be just 1. So it's going to be plus x squared plus y squared plus 49. The left is going to be to the exponent 1. That means if I multiply negative 3 over 2 this side times the second one, the result is going to be, you're going to add the exponents. Negative 3 over 2 plus 1 is going to be negative half. Combine these together. So f sub xx is going to be, I'm just going to keep it like this. This one is going to go down and combine these together because there's a plus. That means x cancel with the x. So the left here is going to be y squared plus 49 divided by x squared plus y squared plus 49 to the power 3 over 2. This is f sub x, the second derivative with x. Plug in f sub xx to the point xy. The result is going to be, because we're going to find it, is that the point? Yeah, the critical point, which is x0 and y0. That means our function xx to the point 0, 0 is going to be, this is 0 plus 49. This is 0 plus 0, 49 to the power 3 over 2. So it's going to be 49 over 49 to the power 3 over 2. The result from here is going to be 1 over 7. Because 49, square root of 49 is going to be 7. 7 cubed is going to be 343. 49 divided by 343 is going to be 1 over 7. So we're done from x, the second derivative with x. Now let's keep going and find the derivative with respect to the y, which is the first derivative of x with respect to the y, which is here. And now we're going to find the derivative with respect to the y. So f sub x, but I'm going to take the derivative with respect to the y. That's mean this function. So it could be the first one times the derivative for the second one. So it's going to be x times the derivative for the second one is negative half x squared plus y squared plus 49 times the derivative of inside with respect to the y is going to be 2y plus the second one times the derivative for the first one is 0. So this one, everything here is 0. Because this is a constant. We need to find the derivative with respect to the y. So the result here, cancel the 2 with the 2, is going to be negative xy over, I forgot the exponents here, which is negative 3 over 2. So over the x squared plus y squared plus 49 to the power 3 over 2. Now, next step, we're going to find f sub xy at the point 0, 0 is going to be 0 divided by any number by x squared. Let's plug in the 0 squared plus 0 squared plus 49. And it's going to be 0. So here is f sub x to the x. Now let's keep going, and we need to find the second derivative of f with respect to the y, which is going to be here. So we're going to use this function. So f, the second derivative of f with respect to the y, we're going to do exactly the same thing what we did here with the x. So it's going to be the first one times the derivative for the second one with respect to the y. The first one times the derivative for this one with respect to the y. So it's going to be negative half x squared plus y squared plus 49 to the negative 3 over 2 times the derivative of this one with respect to the y, which is 2y plus the second one times the derivative for the first one was going to be 1. It's exactly the same steps, but now with respect to the y. Negative half times 1. Cancel this one with this one. And we're going to multiply. So it's going to be negative y times y. So f sub y is going to be negative y squared. And everything here plus 49 to the negative 3 over 2 plus this is 1. So here is x squared plus y squared plus 49 to the negative 1 over 2. Now let's take this one as a common. That's mean f sub y is going to be x squared plus y squared plus 49 to the power negative 3 over 2. And the left here is going to be negative y squared and plus x squared plus y squared plus 49 to the power 1. Let's put this one a bracket so you can know. Now, negative 3 over 2 plus 1, because you're going to multiply these two bases, you're going to add the exponents. So it's going to be negative half. Now, combine the log terms. So it's going to be cancel the y squared with the y squared. And the result is going to be x squared. That's mean this one is going to be f sub y is going to be x squared over x squared plus y squared plus 49 to the 3 over 2. I'm just going to write it down. Then f sub y to the point 0, 0 is going to be, this is 0 divided by any number, so it's going to be just 0. Let's see, wait a minute. I forgot the 49. So now it's 0 over, it's going to be 49 over 49 to the power 3 over 2. The same thing is going to be 1 over 7. Let's write down all the information together and to find the D. Because our f sub x equal 1 over 7. I'm just going to check. 1 over 7. And f x y is 0. And f y y is 1 over 7. Now D is going to be equal f sub xx times f sub yy minus f sub xy squared, which is equal 1 over 7 times 1 over 7 minus 0 squared. So our D is going to be equal 1 over 49, which is greater than 0. So D is greater than 0, and f sub xx is also greater than 0. That means is going to be minimum. If you go back to the first page, if D is greater than 0 and f is greater than 0, so it's going to be minimum. That means the point, the first point we got with x, y, z, which is this one, 0, 0, and the z is 7, is Extrema minimum. So let's plug in this one. That's what we get. So Extrema minimum, that means the point is 0, 0, 7. And here we're going to type D and E. You have to type this one because they're going to consider wrong. That's it for this example. Let's go to the example 3, and we're going to do the same thing, but we have x squared plus y squared plus 2x minus 14y plus 2. So the first thing, how we're going to work on this one, I'm going to find f sub x, which is equal. Let's find the derivative for this fraction with respect to the x. So it's going to be 2x. This one is 0. This one is 2, 0, 0. So 2x plus 2. And then f of x equals 0. That's mean 2x plus 2 equals 0. In this case, x is going to be equal to -1. So this is the first variable, and the first coordinate, and f sub y is going to be, this is 0, this is 2, y, this is 0, minus 14, and let's say f to the y equals 0. To find the critical point, then it's going to be 2 y minus 14 equals 0. That's mean y is going to be 14 divided by 2 is going to be 8. Sorry, 7. So y equals 7. So I'm going to keep going to find the critical point with x, y, z. So I kind of plug in this x and this y here to find the z. So z equal f to the -1 and 7, which is equal -1 squared plus 7 squared plus 2 times -1 minus 14 times 7 plus 2. This one is going to be 1 plus 49 minus 2 minus 14 times 7. I need to choose a save time. So 14 times 7 is going to be 98 plus 2. Now let's combine these together. This is with this one is 0. So it's going to be 50 minus 98. So it's going to be negative 48. Because 1, this is 50. This one cancel with this one. So it's going to be 50 minus 98. It's going to be 48. So that's mean our Z component is negative 48. So I just need to find the critical point at the beginning with X, Y, and Z is going to be equal negative 1, and Y is 7, and Z is negative 48. This is the critical point. Now I need to check this critical point is a maximum or minimum. So I'm going to find F sub XX is going to be, this is F sub X is going to be 2. F sub XY, I'm going to find the derivative for Fx with respect to the Y is going to be 0. And Fyy is going to be 2. Now our D is going to be F sub XX times F sub YY minus F sub XY squared, which is equal 2 times 2 minus 0 squared, and this one equal 4. D equal 4 greater than 0, and F sub XX is equal to, which is greater than 0, then the point negative 1, 7, and negative 4, 8 is extrema minimum. So also we got with this example, extrema minimum. So we're gonna type here negative 1, comma, 7, comma, and negative 4, 8, negative 4, 8. And here we're gonna say D and E. There we go. The example 4 is exactly the same steps. Example 4, our function h is h of xy equal 68x 68y minus x squared minus y squared. So let's check to find our the maximum or minimum point, the extrema maximum or extrema minimum. So the first thing I'm gonna say f sub x is going to be equal, with respect to the x is going to be 68. This is 0 minus 2x. That's it, because this one is 0. Now f sub x equal 0. That means 68 minus 2x is going to be equal 0. And in this case, x is going to be equal 68 divided by 2 is going to be 34. Because we're going to move the x negative to the other side, it's going to be positive, and divide both sides by 2, it's going to be 34. Now f sub y is going to be also 68, and this is 0 minus 2x, sorry, 2y. Let's set fy equals 0 minus 2y equals 0. That means y is going to be also equal 34. Now let's find the z right away by plugging these 2 points here. So z is going to be h to the 34 and 34, which is equal 68 times 34 plus 68 times 34 minus 34 squared minus 34 squared. And how much the result? Let's check that. It's going to be 68 times 34 plus 68 times 34 and minus 34 squared and minus 34 also squared. Let's check everything is right. And this one's going to be 2,312. That's a big number, but it's okay. 2,312. That means our critical point is x is 3,4 and y is 3,4 and z is 2,312. This is our critical point. Now let's check that it's a maximum or minimum. So f sub x is going to be -2. Wow, this is maximum. And f sub x y is going to be, well, here is going to be 0 because here is f sub x. Let's find the derivative with respect to the y is 0. F y is going to be -2. So the d equal f sub x times f sub y minus f sub xy squared, which is equal -2 times -2 minus 0 squared, and this one equal 4. D equal 4 greater than 0. F sub x equal -2 less than 0, which is negative. So in this case, our critical point, which is 34 and 2,312 is maximum. Extrema maximum. That's it for this example. So we're just gonna type here, it's a maximum. So here's going to be D and E. And also here the center point D and E. And here it's a relative maximum. So it's going to be 34, 34, 2,312. That's it for example 4. The same thing is going to be with example 5. So example 5, let's do exactly the same thing. We need to find the maximum relative or its minimum relative. The first thing we're going to find the critical point. So I'm going to find the derivative with respect to the x, which is going to be 2x. This is 0 minus 9. And g of x equal 0. That's mean 2x minus 9 equals 0. That's mean x is going to be 9 divided by 2. It's going to be 4.5. So this is the x. G sub y is going to be -2y minus 6. -2y minus 6. And set g of y equals 0. That's mean -2y minus 6 is going to be equal 0. So in this case, y is going to be equal -3. So we have x and y. Let's find the z by plugging x and y in our function. So z is going to be equal g to the point 4.5 and -3, which is equal 4.5 squared minus -3 squared minus 9 times 4.5 minus 6 times -3. And the result, this is going to be equal -11.25. That means our critical point x is 4.5 and y is -3 and z is -11.25. Now our next step, we need to find this point is a maximum or minimum. So I'm going to say g xx is going to be equal, here's g of x is going to be 2, and g xy is going to be 0, and g yy is going to be -2. So our d is going to be g sub xx times gy, y is -2, and minus 0 squared. So d is going to be equal -4, which is less than 0. That means this point is going to be saddle point. 4.5, -3, and -11.25 is saddle point. So we're just going to type here. This is DNE, and this one is DNE, and the last one is the saddle point, which is 4.5, comma, -3, comma, -11.25. Let's check that. Right, let's go to the next example. Exactly the same thing, but we have our function as g of xy 3xy. So example 6, let's find the extrema, maximum or minimum. That means g sub x is going to be, with respect to the x, this is 1, all this is constant, so 3y. Now set g of x equals 0, that means 3y equals 0, that means y is going to be equal 0. G sub y equal, it's going to be 3x, and set gy equals 0, that means 3x is going to be equal 0, so x is going to be equal 0. So we have x and y both zeros. That means our z, which is g to the 0, 0, is going to be 3 times 0 times 0, which is equals 0. That means our critical point is 0, 0, 0. Let's find g sub xx is going to be 3. Here's g sub x. Let's find the derivative for this one is going to be 0 with respect to the x, because this is all constant. Now g sub x to the y. Here's g sub x. Find the derivative to the y is going to be 3, because the 3 times 1 is going to be 3. And g sub y with respect to the y is going to be 0, because there is no y here. This is all constant. It's going to be 0. That means d is going to be equal g sub xx times g sub yy minus g sub xy squared, which is equal 0 times 0 minus 3 squared. So it's going to be equal -9. That means our d is less than 0, which is right away the point 0, 0, 0 is saddle point. That's it for this example. So we're just going to type here. Well, the next one is the point 0, 0, 0 is a set point. And here is going to be does not exist, does not exist. So example 7, they ask you find all relative extrema and saddle point of the function. By using the second derivative test. So the first thing with this function, we're gonna find the function is h of x, not f. Sure, yes. Then h with respect to the x is going to be 2x. And here with respect to the x, x is 1, so it's gonna be minus 9y. Let's set this one equals 0. That means h with respect to the x equals 0. So we're gonna get 2x minus 9y equals 0. This is the first equation. I can solve it for x or y. So I'm gonna keep it. The second one, h to the y equal, this is 0. This is gonna be negative 9x. With respect to the y, it's gonna be negative 9x minus 2y. Now h with respect to the y equals 0. That means is going to be negative 9x minus 2y is going to be equal to 0. Now I have two equations. It's a system. I need to solve the system to find the value of x or y. So what I'm going to do, I'm going to multiply the first one by 9 and the second one by 2. And let's see, our system is going to be by 9 and this one is by 2. So the first one is going to be 18x minus 81 y equal 0. And multiply by 2 is going to be negative 18x minus 4. Yeah, by 2, 4y equals 0. Cancel these. So 81, negative 81 plus minus 4 is going to be negative 85y, which is equal 0. That means in this case, y is going to be equal 0. Let's plug in y in one of these functions. We're going to get also x equals 0. So 2x minus 9 times 0 equals 0. That means 2x equals 0, so x equals 0. Plug in these two numbers here to find the point. That means our z is going to be h to the 0, 0, which is equal 0 minus 0 minus 0. That means our point is going to be all zeros. The critical point. So now this is our critical point. Let's find h xx is going to be 2. h xy with respect to the y. Here's h to the x. We're going to find the derivative with respect to the y is going to be negative 9. And h y is going to be negative 2. So our d is going to be h xx times h y minus h xy squared. D is going to be equal negative 2 times negative 2 minus -9 squared. So it's going to be -4 minus 81 -4 minus 81, which is equal to -85. Well, this one, this down. 0, that's mean, that's it. We don't have to do, this point is a saddle point. Is saddle point. That's it for this example. We're going to check saddle point, just 0, 0, 0. And we're going to type here D and E. We're going to type here D and E. This is for example 7. And again, we're going to do the same thing with example 8. So example 8, our function is fxy equal -8x squared minus 3y squared plus 8x minus 6y plus 6. Let's do exactly the same steps. So find f sub x, which is equal -16x. This is 0 plus 8. This is 0, this is 0. And f sub x equals 0. That means -16x plus 8 equals 0. In this case, x equal -8 divided by -16, which is equal 1/2. This is the x. F sub y is going to be -6y and minus 6. Now, f sub y is equal 0. That means -6y minus 6 equals 0. In this case, is going to be y equals 6 divided by -6. So y equal -1. So we have x, we have y. That means f to the z, which is equal f to the 1/2 and -1 is going to be -8 times 1/2 squared minus 3 times -1 squared plus 8 times 1/2 minus 6 times -1 plus 6. I got the result equal 11. Yep. Then we're gonna find, that means our critical point is half, -1, and 11. Then f sub xx is going to be -16. F sub x to the y is 0. And f y is going to be equal also 0. Oh no, -6. So our D is going to be f sub xx times f sub y minus f sub xy squared. So which is equal -16 times -6 minus 0 squared. So it's going to be 16 times 6, which is equal 96. That's mean D equal negative times negative is positive. So positive 96, which is greater than 0. And f sub xx equal -16, which is less than 0. Greater than 0, this is less than 0. So that means it's going to be minimum. So the point we have is half. Sorry, if it's less than 0, it's going to be max. If it's less than 0, it's going to be max. So half, -1, 11. If f(x(x) less than 0, is going to be maximum. That's it for this example. So we're just gonna choose the maximum, which is 1/2, 1/2, comma, -1, comma, and 11. And here is D and E, and here is D and E. And we can see if it's right or wrong. Here we go. Last example. For example 9, let's check. Find the absolute extrema of the function over the region. Use again. Okay, here's our function. F of x, y. F of x, y is going to be equal 13 minus 3x minus 3y, minus 2y. 3x minus 2y. So here's our function. The triangle region in the plane, xy plane with the vertex. Let's see. If we do a simple graph here, the first point is 2, 0. X is 2 and y is 0. The second point is, so this is 2, 0. The second point is 0, 1. So it's going to be here. So this is 0, 1. And the third point is 1, 2. So here is 1 and here is 2. So here is the triangle. So the first thing, let's find our region for each point. This is 1 and 2. Our z coordinate for each one. That means z equal f to the point 0, 1. I choose this one as the first point. It's going to be 13 minus 3 times 0 minus 2 times 1, which is equal 13. This is 0 minus 2 is going to be 11. That means our first point is going to be, let's write it down here. It's going to be 0, 1, and 11. The second point z is going to be equal f to the point 2, 0, which is equal 13 minus 3 times 2 minus 2 times 0, which is equal 13 minus 6 is going to be 7. So the second point is going to be 2, 0, and 7. And the third point is going to be f to the 1, 2, which is equal 13 minus 3 times 1 minus 2 times 2. 13 minus 3 is going to be 10. 10 minus 4 is going to be 6. So the third point is going to be 1, 2, and 6. So by just imagining the graph, these points, this one goes up to the z coordinate because this is xy plane. This point goes out 6, and this point goes up 7 with the z coordinate, and this point goes up 11. That's mean this one is going to be the maximum point on the graph of this triangle. This one is going to be between these 2 points, and this point is going to be the minimum. So this one is going to be the max, and this one is going to be the absolute minimum. Here we go, we got it right. So that's it for this section.